All right, nobody actually asked for these, but I felt like just from the general mood, it might be a good idea to give you guys a couple of worked out solutions for the problems you were doing today on binomial theorem. So I'm going to do, this is the one that had 4 questions, and these again are accessible to discriminating. That means the first one should be pretty manageable, and this one should be extremely difficult. This could be an HL level question, and so that might be why the 4th one might be very difficult. So 1 and 2 should be like in our range. 3 is a little bit of a stretch, 4 is a big stretch. So I'm going to do number 2, because this is a pretty common one that IB likes to ask, and that is to find a coefficient of a particular term. And you notice that our terms are already have powers applied to them. So I'm going to use 2 different colors in here. There's my first term and my end term, and this is a 7. And so if I need b to be to the 4th power and my a to be to the 9th power, I can almost sort of start to build this, and that means this b back here, I'm actually doing this backwards, but that's because my color was still red, has to be b to the 4th. And if b has a 4th power on it, that means this thing in the front, the other term, has to have a 3 on it, because 3 and 4, these 2 powers, whatever this is in this circle, it doesn't matter. That power outside of it, and same with whatever's in this red circle, whatever powers outside of that, those 2 powers have to add up to this 7. So if I know that the b has to be the 4th power and there's nothing else in here, then this power outside of the blue has to be a 3rd, which inside the blue circle is 2a cubed. So if I put 2a cubed in here, we can see how the 3 and the 3 is going to get me to that 9 that I need. So I already know that I've met these 2 conditions, because when I apply this power to a power, I multiply. So I've got my a9b4, but I want the coefficient. So this 2 is going to play a part of that, and so is the binomial theorem, which says I have 7. So whatever power's out here is going to go in the top. And if you structure it this way, this guy on the backside, whatever power he has, is going to go down in this part down here. So this means I would have to do 7 choose 4 in my calculator. And I don't actually know what that equals. So I'm going to kind of show you the way I did it. I'm going to leave that as 7 choose 4. And I'm going to make sure I apply this cube to both of these, which means I have to cube the 2. So that is going to become 8. That is a big important thing to make sure you watch. And then I'm going to have a to the 9th and b to the 4th. And my answer is just the coefficient. So whatever this piece equals is my answer. So I don't really care about this anymore because I just asked for the coefficient. So if I were to type 7 choose 4 times 8 in my calculator, again, that's that 7 choose 4, and then you can pull up the multiply symbol if you want, times 8 or times 2 cubed, whatever, you would have gotten 280. I didn't do those as separate steps, so I just punched that in my calculator all at once. So that's kind of how you would approach this problem, looking for the coefficient. And then we'll move on to a slightly more complicated problem. This was the binomial practice from in the class. And I think between 3 and 4, this one might actually be a little tougher because I've got exponents, both variables and exponents in the front and back term. This is very similar to what we just did, where I need x to the 10th. So since this already has a square on it, this would have to have that backside to get to 10 on this would have to have that power of 5. That gets you to x10. And so the front of this, the 3, would have to have a power that would add up to 10. So this would also have to have a 5. And then you kind of build, there's your 10. Whatever this is your choose. And again, it just wants the coefficient. So you're going to have to apply 2 to the 5th, 3 to the 5th, and multiply that by 10 choose 5. So that's a lot going on. So without simplifying, I need to write the 6th term of this. And so to me, that's a little bit tricky. And so when we look at that, it means that whatever, again, I'm going to use 2 colors. I'm going to circle this. So this whole expression is going to sit in the back. Actually, this isn't the one I wanted to do. Sorry. This is the one I wanted to do because it asks for the coefficient of x to the 9, and I've got multiple things going on here, and this is the system of equations. So bear with me, sorry about that. If you need me to go back and do the other one, I can, but this is the one I want to do. I need x to the 9th, and I've got a problem because I got x's here, and I've got x's here. So what I do know as I build the expansion of this, again, this is my result, and I want the coefficient of it. So I don't know where that's going to happen exactly, but I do know as I build this, this 12 is going to sit up in here, and I have to put 2x squared in parentheses because that's my term in the front. I guess I'll use two colors again. And this is my term in the back. So I also have to put in negative 1 over x in parentheses. And whatever powers each of these get have to add up to 12. So I'm going to, and I don't know what that is, some combination of them, but that's why I create my little system here. I don't know what either of these are. Because this already has a power on the top and this has a power on the bottom, when I combine them, things are going to cancel. I don't know how that's going to work. But what I do know is this is my front term, it gets a power. This is my back term, it gets a power. It also means that this has to be b. Because the way I build this, whatever the back one is the number that goes in here. So the first thing I know is a and b have to make 12. So I know my first expression is that a plus b, no matter what they are, have to add up to 12 because they have to equal that 12. Now I'm going to do a little, I guess, power to a power here. And again, I'm going to switch colors on. I'm going to go green. I'm going to kind of ignore all the numbers because I really just want to figure out where the heck does this happen. So this particular power to a power would give me 2a. And this x is on the bottom. So if I put this b down here, it's really 1 over x to the b, which would be a negative exponent, so minus b. So this power, whatever b is, when it gets applied to this x, because x is on the bottom, if I'm comparing it with this, it would be considered a negative because it's in the bottom. And I know that those two together would have to get to 9 because, and I guess over here what I'm doing is I've got x to the 2a, that's what I get right here. And because this b hits that x on the bottom, it would be x to the b. And I'm ignoring all of the numbers, the negative 1 and the 2, because I just trying to figure out how do I get this x9. So if I want this to be written as base of x, it would be 2a minus b, and that has to equal x to the 9. And so 2a minus b has to be 9. Now I have a system of equations. I can come over here and I can add these to get 3a, and this works quite conveniently because these are already set up to cancel, and 12 plus 9 is 21. If I divide by 3, I get a has to be 7. So if this has to be 7, then because these two have to add up to 12, that one has to be 5. And that means this has to be 5. So I'm sorry, I'm just kind of scribbling over top of this. And now I can figure out what the coefficient would be. I'm going to apply all of this so that we can make sure we have this at the end. So again, this would be a calculator function, 12 choose 5. I'm not going to do the Pascal's triangle for that, but I do have to now apply that 7th power to 2. And if I apply 7 to the x squared, it's going to become x to the 14th. And I shouldn't have changed colors, but I did. So I'm going to just put that in red parentheses. And then I will put the next one in blue parentheses so we can kind of see where they're coming from. If I take negative 1 to the 5th power, it's just going to be negative 1. And this is going to become x to the 5th on the bottom. And so now if I take a look at this, my coefficient is going to be generated from 12 choose 5 times 2 to the 7th times negative 1, because those are all my just regular numbers going on there. That's my coefficient. That is my actual answer. But I want to make sure this actually works. So over here, I also have x to the 14th and I on the top and x to the 5th on the bottom. And if I were to simplify this, 14 minus 5, I can subtract my exponents, is 9. So all of this business over here does actually equal x to the 9th. So that's what I was hoping for. And so I know I've got my x to the 9th, and this, typing that in your calculator, will get you your answer, which I guess when I did that, I have negative 101,376 is your answer. And again, this is -1 because it's -1 to the 5th, and so if you raise -1 to an odd power, it stays -1. Hope that helps. If not, give me some feedback. Enjoy your day.